All right, as we got an idea of in one of our previous videos, we saw that we had some Venn diagrams that ended up looking exactly the same, which would mean that the two sets that those diagrams represent contain the same elements, which means that they're equal. So, an application of Venn diagrams is we can show that two sets are equal if we can show that their Venn diagrams match one another. Now, in this instance, what we mean by two sets being equal is we mean the new set you get once you do a bunch of operations. So, we're going to do an example. Show that A intersect B complement, so that whole thing complement, equals A complement union B complement. So we're just going to do the Venn diagrams for the two halves of the equation separately. So first, we're going to look at A intersect B complement, which on your own, make sure that you are really practicing reading these statements, right? Knowing those different symbols, knowing your intersection, your union, your complement difference, all those things. Taking a look at this, we're going to see, well, let's start with A intersect B. So I've got an A and a B inside of the universal set U. And remember, the intersection means the overlap, what's common to both. So that would be this middle region right here. Okay, what we want next is we need to take that, A intersect B, and find its complement. So we need to reverse all of the shading. So in this picture, because remember, a complement means not in that thing. So not in here, but anywhere else. So we're going to shade everything except the middle region. So we're going to be left with everything, but this middle region is left unshaded when we're working through that one. Okay. So that's our picture for A intersect B complement. So now what we need is we need to look at that picture and we need to compare it to the picture for A complement union B complement. Now breaking down A complement union B complement, let's do a picture for A complement first. So I need two circles, A and B, inside of the universal rectangle. Now remember, A complement means everything outside of A. So everything except circle A is shaded. Now notice, remember too, that also includes the box, right? It's everything in the universe outside of set A. And then we're going to union that with B complement. Now B complement, similar idea, is going to be everything outside of the circle for B. And then we need to try and combine those together. And we need to remember how we're combining them together. So in this particular example, the way we're trying to combine them is with a union. Now remember, a union says join the two together. Anything that's in either of them will be shaded here. So we can kind of go piece by piece and see what's shaded in either of them. Notice it doesn't need to be shaded in both of them, just one or the other. So the box works. Everything outside of the circles is shaded in the pictures. Notice in this picture, I have the portion inside of circle B, so I'll shade that. In this picture, I also have the portion inside of circle A, so I'll shade that. Essentially, if you picture it, it's like I took those two Venn diagrams and just overlaid them. So I laid one on top of the other and just shaded everything that was shaded. So just join all of the shadings together and see what we get. So this is what we got. And now my goal is to compare the two final Venn diagrams that we got. Notice we got two of them in different ways, but the final picture represents the set altogether. So notice, if we look at the two, are they the same? Well, yes, both of them have everything shaded except the very middle region. So my final sentence can be, the final Venn diagrams match, so we would have that the sets are equal. So A intersect B complement equals A complement union B complement. If you happen to get something where they don't match, then that would be when you would determine that they're not equal as sets. So that's one of our really nice applications of Venn diagrams that we can use. This example just had two sets, A and B, but there's no reason we can't also do it with more, so we can do it with 3 sets as well. Moving forward, what you guys are going to do next, you've got 2 more examples on your worksheet. So the worksheet for section 2.3. One of them is a question like this. So it's a question where we're looking for showing that sets are equal. So that one will be in its own video. And then the video after it, there's a last question on the worksheet that we're gonna talk through in the video, where we're gonna look at another application of Venn diagrams. Now in that one, what we're doing is, again, we put some things in the regions of the Venn diagrams, but those things don't represent particular elements. It represents a quantity of elements. So in that example, sometimes you use percentages. So you might put a percentage of how many total elements are in those particular regions, or you could just put a numeric quantity of elements in particular regions. And then we can ask all kinds of different questions about how many of the elements are represented in various combinations of our sets. So we're going to take a look at that example just through your worksheet. So finish up those last 2 worksheet videos, and then you'll have wrapped up section 2.3.